どうも皆さん、一日一問英語で数学、瀬戸です。今日はこのような三角関数を使った証明問題をしたいと思います。この問題の元ネタは東大の入試問題です。今日使う英単語はこちらです。So whenever you want to prove some fact about natural numbers, a good tool to use is math induction. So we first show the base case for n equals 1. This is pretty straightforward. The polynomials in question are just x and 1. Now, we do the inductive step. Suppose that we have some polynomials p of n minus 1 and q n minus 1 such that this identity holds. Then we need to show that this will hold for the next step, n. We'll split n into n minus 1 and 1 so that we have something like this. And also, using the summation formula for cosine, we get something like this. But using the inductive hypothesis, we can rewrite these terms so that sine n theta is p of n minus 1 tan theta times cosine to the n theta plus q to the n minus 1 tan theta sine theta cosine n minus 1. But this can be easily fixed to something like this, tangent theta, and using the same trick here, we have something like this. And so by induction, the result must hold for all n. To show the second part, we'll have to use de Moivre's formula. That cosine of n theta plus I sine n theta is cosine theta plus I sine theta to the n. This formula follows from Euler's formula, that e to the I n theta is this term, but that's just e to the I theta to the n. So using the definition, we have cosine to the n theta times qn tan theta plus I pn tan theta is the right-hand side. If we divide over by cosine to the n, we have something like this, but the exponents are the same, so we can combine this to become this. So actually, we have this identity. Now we can take the derivative of both sides, so that on this side, this will be I times n times 1 plus ix to the n minus 1. But when it's n minus 1, it's simply this thing, but with an n minus 1 here. If we match the real and imaginary part, and we get our result. Thank you very much for watching, and please subscribe to our channel.